Okay, so in this particular video, we'll be looking at the question number 2 in tutorial 14 of AutoCAD. So here you can see that they've given us two views. So we've gotten the top view of this diagram, and we have the front view. But the difference from this exercise to what most of the exercises that you have done before is that here they've given us the view of a cross section of this diagram. So it's not just a cross section in one plane. Okay, so this cross section runs from this point and it runs along this center line to this point. So basically what you have here is the cross section or the view that you would see if you were to cut um, this object along this line. Okay, so to represent some of the solid bodies, when you normally get a cross section view to represent the solid part of that of the body running along this plane, we use what you call this feature, the hatch feature. Okay, so it's normally filled out with this feature known as a hatch feature, or you can even use gradient or boundary. But here you can see that they have included a hatch feature here. So we'll look at how we can implement that, what are the different standards associated with hatch feature. And yeah, so let's start this diagram. So we can start off by denoting our layers. So again, you only have two types of layers. You will have the center line and the continuous line. So you can go to layer, select new layer, have one for center line. Change the color to something light. I'll use light red, and change the line type to center line. You can select the option load and select center. Okay, so now I have my two lines. So when you normally have two views, the best way to draw is to start off with your center lines and then offset to get the rest of the lines. So I'll start off with these two center lines. Keep in mind that this center line extends from just the top view to the front view as well. So make sure that when you're drawing this center line, it's long enough to extend to this view as well, so that we can get it with one attempt without rather than drawing two center lines separately. So again, the total width is 2.38 and the height is 1.58. So if I draw a center line of around 10 millimeters, again we can assume the unit sign millimeters. If I draw a center line of 10 millimeters, that will be acceptable. Okay, so something like this. Now I can draw this center line, and that line should be greater than this total width. So the easiest way to draw this diagram would be to draw half of it and then mirror to get the rest. So for now I'll just draw the center line. For around 10 maybe. I'll increase it up to 20 tabs, 0. Okay, so this center point represents this one right here. So now we can start off it. So here, as you can see, I can straight away draw these two circles. But the problem is, if I do draw this circle, I'll have to draw this line separately. So the edge of this circle is what's represented here in this line. Okay, so this line is basically used to represent this hollow shaft that runs through the object. So the best way that I can get this point would be to offset my center line by a distance of, so this is the diameter is 1 and 1.63. So the outer diameter is, I believe, 1.63 and the inner diameter is 1. So I can offset this line by 0.5 to get uh, not just this circle, but I could get this line as well. So both in one attempt, or in a single attempt. So that would be easier. So select on, okay, so before I move on to that, I can probably get these two center lines as well, this, and hopefully these two as well. So yeah, it'll be easy if I complete those two, and then I'll move on to the circles. So offset it by 2. And again, I don't have to draw both these circles because I can just draw this and then mirror it to get this. And I'll have to offset this line by 0.5 to get this center line. So offset this by 0.5. And now I can offset this by 0.5 to get this line and the circle, both with one attempt, by 0.5. And again I can use it to get this line as well. So that's going to be 1.63 at a distance of 0.25. So what they have told us um, in this line is that there's going to be an outer circle of diameter 1.63 with a depth of 0.25. Okay, so this 0.25 is this depth. So 1.63 divided by 2, that's 0.815. Okay, so now we have that as well. So again we can change these lines to, since they are not center lines, we can change it to the continuous line format. This is a center line, and yeah, these are all center lines. Okay, so now I can offset yeah, so now I can offset this center line by how much, 1.38 to get the top line, and I can offset it by 1 to get the bottom line as well. If I offset it by 1 to get the bottom line and offset it by 1.38 to get the top line. And I'll have to offset this by 1 to get this solid line. So you can change all that to the continuous line format. And again I can offset this by 2.61 to get this line. So now we have the outer line here as well. Okay, so now I can look at completing these components. So first off, let's start with the two main circles here. So the circle of radius or diameter one. So we'll select the center diameter option. Yeah, I'll change the layer type to continuous. And the diameter of 1. And similarly with the diameter of 1.63. So now I have these two circles. What I'll be needing next is I have this line as well. I'll have to draw these two circles. So that's going to be circle of diameter to 0.38 and another circle of diameter 0.75. So the intersection point is here, 0.38 in diameter, and again of 0.75. So now we can try to trim off the unnecessary sections here. That will make this diagram a little bit easier to deal with since there are so many lines. So go to trim. And I can always mirror all these lines to get the opposite uh, correlating lines as well, just to make it easier. So again, I won't be needing these lines, but you can go to mirror, select the objects you want to mirror. So I want to mirror this, 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 and this. Okay, maybe not this. And again, I can mirror these components to get a line at the bottom. Oh, sorry, circle at the bottom. And again, we can mirror this line to get the center line running through the circle at the bottom. So select that, go to mirror, and you can select the line. Okay, so now we're pretty much completed with the top part of this diagram. Later we can move on to entering the dimensions, but for now we'll keep it like this, and we can move on to the bottom section. So here what we want to do is we want to mirror these lines again to get the same lines on the opposite end. So you can select these lines and select the mirror option. And again, we can offset this line by how much is it? It's, 0.19 and 0.375 to get these two lines. So go to features, go to offset, 0.19. And again, we can offset it by 0.375. And we can mirror those lines to get similar lines on the opposite end as well. But before we do that, we can always change the line type to continuous since that's what we want. So change it to continuous and mirror it about the center. Okay, so now we have all the horizontal lines that we want. So now we can start off by drawing this line first, and then we can offset it to however much we want, and then we can uh, complete this diagram by drawing the horizontal lines. So go to line, and this line should be 5.22, so that's 2.61 times 2. That's correct. Now we need to offset it by 1 and 0.75. So 0. The distance from this line to this, or the vertical distance, is going to be 0.75. So that's basically 1 minus 0.25. Go to offset, select line, so it's going to be 0.75. You can offset it by 1 to get the top line, and again by 1.25 to get this line. It's going to be 1.25, and again by 1.5. Okay, so now we can start to trim off all the unnecessary sections. So we can start off by trimming out these lines. Okay, so we won't be needing any of these lines. So what I basically marked, the two lines that I marked are this line and this line. Okay, so everything that's here is what's outside here, so we don't need any of that, so we can trim that out. We can trim that out as well. We can trim out the unnecessary section in this part of the drawing as well. So what we need is this line is this. sometimes when you try to offset like this and trim the unnecessary sections, it can get a little confusing, but this is actually the easiest way. So once you get used to drawing, this will actually be pretty easy for you once you get the hang of this. Okay, so now yeah, this should be the finalized diagram. So yeah, now we can remove the unnecessary lines from this. Okay, so and we want to make sure that the center line does not overlap, since we want to clearly show that the cross section runs through this center line. Yeah, we can adjust that also by trimming out these lines. So what we can do is go to layers, select center line, select line. Again, this doesn't have to be accurate since they are also not given us proper dimensions regarding this. So they've drawn a line here, so that's on the left side of this line, so we can plot something similar to that. Similar here too, so this is to the right side of this line. So go to line, now we can trim off the unnecessary sections. So now later we can clearly show that this is the A and A section. So again, this you can't clearly see that this is a center line, so the best thing you can do is go to LT scale and change the adjust the scale. So go to LT scale into something like 0.5 maybe. Yeah, now you can see it's center line. So now we'll quickly enter the dimensions and we can move on. So we'll have to enter the fillets here as well. So as you can see, even though it's clearly not mentioned here where they have actually entered the fillet, you can see that there is a fillet here. So you have fillet here, you have fillet here, here. It's maybe in the corner. You can't clearly see if you have it in the corner, so you can't see it from the top view. So we'll have to enter some fillets here. So go to fillet option, select multiple, give a radius of 0.1, multiple. So there's an additional line here. Let me erase that later. So we have entered the fillets as well. So now we can just enter the dimensions fast. So this has to be 2 point. Okay, let's change the line type. Sometimes you can define a different layer for your dimensions as well, but I use a continuous line to define that as well. So dimensions, so that's 2.38. This 1.8. 1.5 and this is supposed to be 1. This is supposed to be 1 point, so this is supposed to be 1 comma 1.60, so again you can enter that. So go to insert symbols, degrees sign. Supposed to be diameter, so 1.00. Let's see if you can maybe try to find these symbols. Again, you can obviously find it and day by day it will be a bit time consuming. So since that's not the main focus of, okay, so it's you had the indicator here to show that this is the depth actually. So we'll enter that. .63, the depth of 0.25. Okay, so similarly have a dimension that you enter here as well. So this will be 2 times insert diameter 0.38 enter the depth of 0.25. Yeah, so that's accurate as well. So we have completed the dimensions of the top view. Now we can move on to the bottom view. So that's just, we have 2 dimensions there, so we can complete that quickly. So this is 1 and this is supposed to be 1.5. Okay, so now to the important section of this video. So like I said before, this view is basically the cross section view that runs along this center line. Okay, so it's not actually in one plane, it runs along 2-3 different planes, and that's the front view that we have here. So normally when you get a cross sectional view to represent the solid parts that are running along this plane, so that's basically this initial part, and then you have this part, and you have this line, this, this, and this. So to represent those parts, we need to show that in our diagram that these are solid components. So to do that, we use the hatch option here. So again, you have, so let's select this, and you can enter again. So to enter a hatch, you need to have an enclosed region. So here I have an enclosed region. I can select this, 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 and this. Okay, so now I've entered my hatch to indicate that these components or these sections are actually closed, solid components that are running along this plane, this A to A plane. But you can see that this pattern is a bit different to mine. So the one that I have had, or the default hatch that you get, is just basically straight lines. So if you again, if you want to change any, let's say you have a sort of bigger diagram than this. So if that's the case, then if you enter the hatch with the normal properties that they have already given in AutoCAD, then it can be like too small for you to see. So you can change the size or the spacing of these lines in the hatch by adjusting this. So this is basically known as a hatch pattern scale. Okay, so see what happens when you increase this. So the more you increase this, the larger the space between the two lines become. Okay, so again, if you have let's say sort of big diagrams, you can always and if you enter the hatch property with the given set of properties in AutoCAD, you'll see that it's very small, so it's hard to identify that as a solid component. So that's why you have this hatch pattern feature here, and you can always adjust the angle and the transparency of your line as well, and you can change the direction as well. Okay, and you have different patterns here, so you can go with solid, gradient, or the pattern that we have used here. Okay, and another thing is, so you have different standards here. Okay, so under pattern, you can see that the default standard that you get is ANSI 31. Okay, but you can see that in the diagram we had something like this, ANSI 33. So that's one line, and then you have a center line, one line, center line. So that's the pattern that you had in this drawing. I don't know if you can see it clearly, but um, that's what you have here. So make sure that you select the proper pattern, and select the proper stand that you want to use to indicate the solid area. Okay, so that's it for this video. Make sure that you try to alter these properties here, just to see how you can get maybe the lines on the opposite direction. So what would happen if you increase or change the angle or transparency. So make sure that you try out all these options, and just to make sure that you are familiar with all these options. So that is it for this video.